Hey, did you know they made switch mode power supplies in the 1950s? Here's one right here. It's a 1950s power inverter, and it's mechanical. So they made mechanical switch mode power supplies way back when. Let's repair this thing, bring it back to life, listen to how loud it actually operates, and see what we can power up with it. Let's get started. 6 volts goes in here, and we get 110 volts AC out of here. So for example, this would take a big old 6-volt lead acid battery. So for example, an old car battery. Older cars used to have big old 6-volt batteries in them. This would clip to the posts on those batteries. And if that's not neat enough, we take a look here. It says voltage regulator. None of this automatic stuff. You set the regulation yourself. So we can obviously vary what's available at the AC outlet. So I guess this would be somewhat like antique overclocking, something like that. I don't know if it speeds the vibrator up or down. I don't think it probably does. I would imagine the vibrator might change under load, the speed of the vibrator a little bit. I really doubt that it's at a purely fixed 60 cycles anyways. So it could be possibly considered antique overclocking. Look at that. So we have 3 terminals here, hot, which would be positive to the battery, ground, which is obviously ground, and control. Now control might be very similar to what you'd find on a modern auto amplifier, like an automotive stereo amp. Maybe it needs a positive to run from here to turn it on, or maybe even from here to ground. So I noticed that this one's black and this one is black, where this one is red over here. So there might be, might be from here to here. I don't know. We'll find that out as we go along. In fact, you know what? Let's power this thing up. Let's do that right now. Let's see what happens. So I'll move you up here to the power supply. And we'll zoom into the upper one. So I'll turn this on, see where we're at. 7 volts, that's fine. This isn't regulated either, so you have to adjust this. It's manually regulated, none of this automatic stuff. Positive on that terminal and not on this terminal. So can you guess which one is positive? So let's click this one here. And we'll put this here and see what we get. Okay, the thing is on, so you can see nothing is happening. We'd see current draw if something was happening here. You see it's on down here. So what I'll do is I'll take a battery lead, or just a wire, I'll take just a standard little clip wire and connect control to negative. So with this thing here. So it's supposed to focus on this little clip lead right here. Okay, so control, it's clipped on that to negative. Keep an eye on this, see if anything happens. Nope, nothing is happening. And now control to positive. Nothing is happening. So this thing is definitely not working. So you know what we should do right now? It's the thing that any electronics engineer will do the last. Can you guess what that is? We'll redesign an entire circuit board because it doesn't work. Then we'll go, oh, let's check the fuse. In this case, it's looking okay. A little crusty and a little bent in the middle, so it's obviously been drawing some form of current, right? But it's okay, so let's put that back. And it latches in there kind of nice. You know what? Now it's right side up. Let's take this thing apart and make it work. Let's listen to this thing buzz away, because you know it's going to be loud when it's operating. Look at all that wax capacitor goodness in there. That's good stuff. Smells like an old radio too. So look at this. The AC outlet right here has wiring shielded into a shielded can. So they're obviously trying to keep noise down. So this would probably be good to power up an old radio or something like that. Because of course, with, you know, a mechanical oscillator inside here, you're going to have arcing and sparking going on, so they want to keep everything nice and shielded. Let's see what we got in the backside. That's on there pretty good. Usually you have to pinch the sides in before you push the cap on. So that's the way that these all were. Imagine this thing could use a nice hammer tone repainting. There we go. Oh, and look at that. So that is the mechanical vibrator right there. And it says original on it, so how could we argue that it's original? Look at that big old transformer. Now don't be fooled by the color on the windings here, because they coat the whole transformer with this, you know, brown sort of, almost like an epoxy. It's a varnish that they coat this with. So that's not burnt, it's just what they've coated it with. Normally these things unplug, so let's see if I can get this out of here without too much grief. Look at that. So they put these little rubber mounts on them to try and lower vibration and things like that, right? Because these things buzz. So, let's see, what does it say here? Well, American Television and Radio. That's what that stands for. ATR. Kind of neat, huh? So chances are we're going to probably have to get in here and work on this thing, because most likely this is going to be the problem. Almost all of these old devices, when they don't work, it's this thing. And of course, the capacitors, wax capacitors, need to be replaced out. Now the ones that are on the lower voltage side, you know, probably not too incredibly bad, because they're not in a very high impedance circuit. But the wax caps in these things, you know, are grief. So I'll move some stuff out of the way here, and let's see if we can just get this thing to buzz. Let's verify that the problem is in this and not in that. Well, we won't know until we get this fixed and put back into that. Maybe there's problems in there as well, but let's see if this is the beginning of our issues. So normally in these larger type oscillator cans, these are used in a lot of the old transmitters as well. So you start counting, these are the two large pins, so you start counting from here clockwise is how you work out the pins. So you got pin 1, pin 2. So pin 3 and pin 4 are usually, now I don't know if it's connected in this device here, but are usually connected directly to the coil at the top. And the coil is this basically a bobbin of wire, and then there's a weight below it. And if you apply current to those pins, the weight will pull over to one side. Now, it won't oscillate because it has to go through another connection. So what happens is there's a connection being made, and when this pulls over to one side, it breaks the connection, and then it falls back again. And it makes connection, and then it creates this pendulum effect, which gives us our oscillator inside this unit right here. So what we can do to make sure that that coil is actually okay is we can check pins 3 and 4. So we go pin 1, 2, 3, and 4. So I have a current limited supply, so I'm not going to damage this thing. These things are brute force. You're not going to damage it even with a high current supply, but let's put some current on here. And I should feel it kind of go bonk as it pulls the weight over. Bonk. You kind of feel a little bit of it's kind of like a rubbery feel. And it's doing it, so the coil is okay. So I'll put this close to the mic and I'll let you hear it. So here we go. So you hear that? How it's kind of pulling over? You can kind of hear it pull over like that. So the actual coil is okay inside this. Now, usually a combination of one of the large pins and one of these pins up in this area will start the thing oscillating. So what I'll do is I will move from one of the large pins and just go around in a circle. Again, this is current limited, so even if a contact was closed, nothing is really going to get bothered by it. and we have nothing going on here. So I'll just move to every pin on this to see if they've been tricky and they've changed the pinout on us or done something silly like that, right? Because, you know, they do those things. Nothing is happening. It would make a lot of noise. There's that bobbin again. They make a lot of noise when they run, so, and if it was to start, we would know it. There's that bobbin of wire in there again, the little coil. And there's just nothing going on inside this. We'll go around here. So the next thing that we need to do at this point here is open this up. You might be asking yourself, Paul, why are you using a pipe cutter? And as you can see, I'm just about done. Well, the reason is this is a metal can. And the nice thing about the metal cans is, see, we've already got this open here. So the nice thing about the metal cans is this actually puts a bit of a, you can see how it's kind of tapered the edges in. So when you want to put this back together, you can put it back together, you can solder this very nicely. And then what you do is you file it even with the can, and then you throw a coat of paint on it, and you don't even know you've cut this thing open. So this is only valid with the metal cans. Of course, the aluminum cans, you can't do that with. A lot of the times you open them on the bottom, and they always end up looking messy later on. But this way you can leave this nice crimp on the bottom and open it above the actual line in the case itself. Here, I'll show you. There's a line here with a bunch of, you can see this here, see these little fingers here? All right, you want to basically cut it open above that line there so that it doesn't interfere with, these little fingers here are what hold the can inside the power supply. They hold it steady. So you don't want to cut it below that, right? Because that's obviously going to, you know, press on that solder. But, you know, cut it just a bit above, like what I've done here. And in the end, you get a very, very nice looking restoration with this product here. So now the whole thing is still a little bit of a connection here. Hopefully I can get this open without too much damage. Might actually need to put that back in there. There it is. So now when we open this, you can see how this all just comes out. And there it is. There's the coil on top that I'm telling you about, the pendulum that moves around. And those contacts and this contact here is the offender. That's what's stopping this unit from working itself. I really like opening the actual cans this way. It really makes it look quite nice. Even with the unit taken apart, it still looks really good. Again, if you usually pry this seam open at the bottom, they just look horrible when you're done because there's no way you can't make that not messy looking. So you can use some Kapton tape on the inside here when you put this back together. Of course, you have to sand the finish off of this, right, because this is plated. And yeah, they solder together very, very nicely, right? So it's very, very easy to fix. So anyways, these things right here, you can see how this pendulum moves back and forth and we get an oscillation that happens there. So usually what happens is we need this to break. So what happens is pulls over, this breaks, as you see that there, and then it comes back and touches this. And as you can see, the contacts move back and forth like so, and that's what gives us our oscillation on each side. So what I'll do is I'll go get some sandpaper. I'll just quickly run some sandpaper in these contacts here, and we'll see if we can make this thing start up again. And if it starts, we'll just plug it in the way it is and see if the actual rest of the power supply works. Just before we dig into this, I'll give you a quick look at how this works. So you can see the contacts for each side. We have dual contacts, right? Two sets of contacts. And what happens is you can see there's a gap between them, right? None of them are touching. So this is connected to one side of the transformer winding, and this is connected to the other side of the transformer winding, and usually the center tap will go off to positive. And then what happens is you can see we have a contact that's being made right now in the center. So what happens is this magnet pulls this over like this and breaks that contact. All right, so when this contact breaks, we lose power to this coil and it falls back. And then it makes contact again, we get power to the coil, it pulls away again, and then it breaks the contact and it falls back. So we get this oscillation. Now you're probably saying, well, if this stops here, how does that close, right? Because this one's going to close when this pulls over, but you can see that one doesn't look like it's closing. Well, when this gets momentum going, you get that overshoot effect, and you can see how it's closing this side, then closing this side, this side, this side, and that's the reason that this is spring-loaded in the center as well. See that? So it's basically a mechanical TL494 without feedback, right? And that's what this is doing. It's just going back and forth just like this. Or is the other version M51995? Is that the other version? Anyways, so that's all it's doing. It's a mechanical oscillator that's basically acting kind of like breaker points in your car. And what it's doing is it's, hitting one side at a time in the transformer back and forth, right? So depending on the configuration of this particular device, sometimes the center tap will be to ground and it applies positive to each end, or depending, sometimes the center tap is positive and it'll ground each end. So it just depends on the particular type. You have two different types, right? And that's how it works, just like that. So the main thing that's stopping this from working is this connection right here, most likely, right? So I don't know if I can get any closer to that. I don't think I can. And let's see if I can get this any closer for you. All right, so I'll just hold this here. And you can see how dirty that contact is. Keep that perfectly in focus. So we might get this to start when we get this one little contact here clean. So I will go get some paper and we'll see if we can clean that up just a little bit. Spray it down with some contact cleaner as well. So what I do is I get a piece of 400, usually wet sandpaper. It's nice and it's durable. It doesn't really fall apart when you're doing this. Fold it over like so. Just move the contact back. Stick it into the contact. Just let the spring pressure hold it. And then just move it in and out like so. Look at what's coming off of that already. And that's all. As you can see, it's cleaning up. So what I do is I push down. A lot of the times the surfaces in these are not perfectly even, right? Because these things have been running for years and years and years. And that's probably going to be good to get the thing going. Sometimes we'll have to adjust this here in order to set the gap again. Now that that's done, we want to make sure that we don't have, any grit in there, right? So what we do is you just take your favorite contact cleaner and just give it a bit of a blast just to clean that out. And you're usually pretty good. One added piece of protection that usually works pretty good is you can take that same piece of paper and fold it the other way and use the back side of the piece of paper, stick it between the contacts, just like so, and then just run that in there like so, just to make sure that there is, no grit from the paper left. Now, I'm not sure if that's going to be enough to start that. We haven't cleaned the other contacts yet. The other contacts are cleaned exactly the same way. So basically, these ones here don't have as much spring tension on them, right? Because they're kind of open already. But you would take this the other way around and just do the same thing to these contacts here. So you're just going to sit there and spend your time and move in and out of all of these larger contacts the exact same way, pushing down and all over the place. And then when you're done, you're just going to give that a blast again with some contact cleaner. But we've cleaned this upper one here. Let's see if we can get any action out of the little pendulum here. So I will see if we can get any contact here. Now normally, it's usually this pin here. Let's see if it is the same type, or not. No, it is not. So there is some other pins that are going to actuate this. Could even be the rust, Maybe that's stopping the connection here. So we'll have to find out. So we have the pendulum here. I'll show you that. See how that's pulling that over? This is me touching that. So we should have another connection to here that will allow this to make and break contact. So let's move it back and forth and see if we can bring it into connection. Oh, look at that. You can see the amount of how far that's moving and what the overshoot of that is in order to make this make connection. Isn't that nice? So, in this case, it's the pin over. So this is probably opposite of the ones that I'm used to, because the other ones are normally to this pin here. So this might have reverse polarity. Bring that close to the mic so you can actually hear that and see that. You can hear how noisy that is. Isn't that crazy? Now that's not the only spark that you get. When this thing is working inside the power supply, all of these ones are sparking too, because it's applying. This is just switching. That little spark that you see there is just applying the current to this thing, right? So when the actual power supply is working, these are making and breaking that huge transformer in here. So I'll grab this here again and show you this. These leads out of the way. So that's making and breaking the contacts to this. So you can imagine the kind of sparking that's going to happen from that. So there's obviously going to be some snubbing caps in that box. The contacts are all cleaned, and surprisingly enough, they have extremely low time on them. There's hardly any pitting in these contacts at all. They look brand new. So that tells me that this has very low time on it, and that's probably the reason that it still has the, original part inside of it, right? So original ATR. So I did take a picture of this, by the way, so when I go about restoring this, I can make a brand new label for this to stick on this. So I always do that before I go about, running a pipe cutter and that over top. So there it is. So you know what? Let's put this thing in here and see what happens, right? Of course, there's, all these old wax caps and everything that should get replaced, but let's just see if it'll even start. How about that? So I need to align the two large pins here to the two large pinholes right over here. And sometimes that is a little fun to do when you can't see under the device. That went together pretty easy. So that's in there. Okay, so what do you think's going to happen? Let's see. Grab these leads and attach them to a not so current limited power supply. And turn this off. All right, let's see. Aha! Life. So, give me a moment. I'll go get something to plug into this thing that I'm not going to worry about, and I'll be right back. Okay, dim bulb tester light bulb in one of these fancy plug-in sockets. Let's see here. That should be making enough connection. That's a really, the connections in this are really tight. Again, another sign that this doesn't have all that much time on it. It looks like it's been in a pretty rough environment though. Okay, so here we go. Haha! There's life. And it's pretty bright too. You can hear it change. It's working. Just as easy as that. That's all it took to bring this ATR unit back to life. If you'd like to see an entire restoration on this unit, and I mean entire, painting of the case and everything, let me know in the comments below, and if I get enough requests, we'll revisit this and I'll do that entire restoration. Are you interested in learning more about modern and antique electronic devices alike? Would you like to have the ability to troubleshoot and repair both older and newer electronic devices? Would you like to see just under 200 videos dedicated to teaching you all about electronics with projects for you to build? And you also have access to my personal electronic inventions and designs, many of which you've seen here on this channel, and I've open sourced a few of them, so they're all over the internet. If you are, you're definitely going to want to check out my ongoing electronics course on Patreon. I'll put the link just below the video's description under the Show More tab, and I'll also pin the link at the top of the comment section. So if you click on that link, it'll take you right there. If you enjoyed this video, you can let me know by giving me a big thumbs up. And don't forget to subscribe if you'd like to see videos as soon as I post a new video here on YouTube. All right, until next time, take care. Bye for now.